In this lecture, I want to talk about kind of some more abstract problems. The problems that we've looked at so far with respect to quadratic equations have all been pretty concrete. Take a specific equation or a specific word problem kind of scenario and calculate the result. In this case, I want to be a little more abstract for those of you who are maybe going into fields like engineering or physics, where you need to be able to work with these equations and formulas kind of at that theoretical level as well as a more practical level. So here I have two numbers, and I want to come up with a specific quadratic equation that has those numbers as its roots. Right. Well, I want to just so you can kind of see the reasoning here. Let's look at a different problem. Let's look at the equation x squared plus 5x minus 6 equals 0. And I want to think about how we solve this, because to answer this question that I've asked here, we're going to kind of follow the same process in reverse. Right? So remember, our method for solving this is we say, okay, well, I picked nice numbers. I picked numbers where this factors, and this is x plus 6 times x minus 1 equals 0. And then we use our little theorem here, right? And we set the factors equal to 0, and we get two solutions. X equals negative 6, and x equals 1. All right, so now let's go to our numbers here. I want to find a quadratic equation whose roots are x equals 3 and x equals negative 2. Well, look at what happened over here, right? These two roots came from these two factors, right? So if I kind of work this backwards, if I set each of these two little equations equal to 0, I get x minus 3 equals 0, and x plus 2 equals 0. Now this gives me the factors to the equation that I'm looking for. My factors are going to be x minus 3 and x plus 2. And if I multiply this out, I get x squared minus x minus 6 equals 0. And you can check our work here real quick. If you substitute 3 and negative 2 in for x, you should see that polynomial does equal 0 for both of those values. Both of those values are its roots. Now, I want to emphasize something here. Right? You notice I worded the question very carefully. Notice I said find a quadratic equation. Right? Because let's consider this equation. Let's say we had the equation 2x squared minus 2x minus 12 equals 0. Right, hopefully you see what I did there. I just took my equation and multiplied the whole thing by 2, and I got this different equation. Right? This is a different quadratic equation that also has those same two roots. So this method is nice in the sense that it gives me an answer. It gives me a quadratic equation that has the roots that I want. But you should keep in mind that it is not giving you the quadratic equation whose roots have those values. In fact, we don't have it to narrow it down to one equation. We don't have enough information. Basically, we know 2 points on the equation's graph, and with a quadratic equation, that's not enough to get one solution, one equation. We would need a third point to do that. All right, so let's look at another question, more abstract here, right? I have this equation with certain parameters in it. I know that for some reason, the b and c values both have to be the same. And I want to know what values of k give me a single repeated solution for this equation. Well, anytime we're referencing the parameters, the a, b, and c of a quadratic equation, and I want to know something about its roots, the first place I immediately think to go is the quadratic formula, right? The quadratic formula tells me that the roots of a quadratic equation are x equals negative b plus or minus the square root of b squared minus 4ac over 2a. All right, now let's think about how this applies to our equation here, right? With our equation, a is 1, b is k, and c is k. So if I substitute those numbers into my equation, what does it turn into? This becomes negative k plus or minus the square root of k squared minus 4 times 1 times k over 2 times 1. All right, and I want this equation to have a single repeated solution. Right? That's what it means for a solution to be repeated. It means that there's only one solution. Now, to do that, I have to somehow get rid of this plus or minus part, right? The square root here, because this is the part that turns the negative k into two numbers, right? So the only way I'm going to, in a sense, get rid of this part of the expression is if it's equal to 0. So that's what I'm looking for here. I want to know what value of k makes the square root of k squared minus 4k equal to 0. All right, now this is nice because now this is an equation I can solve, right? If I square both sides, kind of following our process for solving a radical equation, this becomes k squared minus 4k equals 0. Now the left-hand side, that's just a quadratic equation. So if I factor this, it becomes k times k minus 4 equals 0. And this gives me two answers. K equals 0 or k minus 4 equals 0, which is the same as k equals 4. All right, so I got two answers, right? And that's okay. You know, that often happens with quadratic equations. And we can check this real quickly. If I put these two numbers in, if I put 0 into the equation for k, what happens? It becomes x squared plus 0x plus 0 equals 0. That simplifies to just x squared equals 0. And yeah, that does only have one solution. X equals 0. And if I try it again with 4, let's see what happens. This becomes x squared plus 4x plus 4 equals 0. And this thing factors, right, to x plus 2 squared equals 0. And it worked again, right? This only gives me one solution. X equals negative 2. All right, so let's try one more here. I want to show that the sum of the roots of a quadratic equation is negative b over a. All right, well, structurally, this question is very similar to the previous one. I know I'm talking about the b and the a, right, the parameters from the general form of a quadratic equation, and I'm talking about the roots. And the way we get to the roots is by looking at the quadratic formula, right? And I'm going to write this a little differently than we usually do. I'm going to actually write the roots separately. The quadratic formula gives us two solutions, negative b plus the square root of b squared minus 4ac over 2a. And it gives me the second root, that's negative b minus the square root of b squared minus 4ac over 2a. And this question is asking me to show something about the sum of the roots. Well, I'm just going to be very brute force here. I'm going to add these two things together. I'm going to look at the sum of the roots. That's x1 plus x2. So that's negative b plus the square root of b squared minus 4ac over 2a plus negative b minus the square root of b squared minus 4ac over 2a. And this is nice, right? We got a little lucky here. The denominators are the same already. So I can just add these two together. This becomes negative b plus the square root of b squared minus 4ac plus negative b minus the square root of b squared minus 4ac, still all over 2a. All right, now here comes the cool part. Look at what happens to those square roots. I have plus b squared minus 4ac minus the square root of b squared minus 4ac. These two cancel. All I'm left with is minus b plus minus b. That's minus 2b still over 2a. The 2's cancel, and I'm left with negative b over a, which is exactly what I was asked to show, right? So first, I want you to think about what we did here, right? These are kind of classic techniques for answering questions about the roots of a quadratic equation. I hate to say all the time because they're going to be unique situations, but a lot of the time, to answer this kind of question, you're going to go to the quadratic formula, and you're going to work with it, manipulate it somehow to get the solutions that you're looking for. One other point I did want to make here. Let's say we try to apply this here. Let's say we look at this special case that you usually talk about in algebra classes. Let's say we have this case x squared plus bx plus c equals 0. When you're first learning to factor quadratic polynomials, this is where you usually start. Right? You start by looking at the special case where a is equal to 1. All right, so for this polynomial, let's look at what our formula says. In this special case, the sum of the roots is negative b over 1, which is just negative b. Right, and I want you to think about how you learn to factor these. Right, there's a process that you learn where you're looking for numbers whose product is the c term, and whose sum, and we're talking about the sum of the roots here, is the b term, right? And we see here why the sum of the roots is equal to the opposite of the b term, right? But when you make the factors, remember if we have thinking back to the first problem we did, if we have x equals 3 as a solution, then x minus 3 is the corresponding factor, right? So this idea that the sum of the roots is equal to this formula based on a and b is kind of the theoretical basis behind that method that everybody learns in algebra for factoring this special kind of polynomial, special kind of quadratic polynomial.